So just a recap. Let's just do a recap on what we learned yesterday. We saw that if you have a collection, if we have a collection of type A, on that we can have a for each higher order function, and we can pass a function to that higher order function which will be called for every element on the collection. Since it is called for every element on the collection, that function takes the input parameter as the element from the collection. Hence, that both has to be of the same data type. The collection data type and the input parameter to the function should be of the same data type. And it returns a unit. And we said that unit means it is a mutability function. So whenever we want to save the data of a collection to some external store, so we always use a for each. Storing the elements of the collection to external store, you use the for each. The external store could be anything. It could be our console, it could be an external database, or it could be a message queue or some global structure. It could be anything. In a similar fashion, yesterday we saw if we have a collection of type A and we want to transform each element of that collection, we use the map higher order function. We want to transform each element of the collection, we use the map higher order function, which takes a function and that function takes an element from the collection and transforms into some other type, finally returning a collection of type B, whatever it has been transformed to. In a similar fashion, we saw filter higher order function. Whenever you want to filter out some error records, we can use the filter higher order function. Some filtering, not necessary it has to be always the error record. Some filtering you want to do out of all the records in your data set. You want few of the data sets based on some condition. So you can pass a function here which takes each element and applies a logic, and if it returns a boolean, that element will be contained, or it will be taken into the destination collection, otherwise it will be discarded from the destination collection. We saw this yesterday as well. Since we don't change any type here, we are just filtering the data, filtering the records. The collection will be of the same type. The type doesn't change. In a similar fashion, we also saw a reduce higher order function, which takes a function and takes two parameters of the same type as the collection type. It doesn't take some other type. It takes the same type as the collection type, and it returns the same type as the collection type. In fact, actually it returns a slightly different. It returns a slightly different, which means it could be a superclass of the actual collection. It could be a superclass of the actual collection. And finally, it returns a event actually. So we know that. So the reduce itself says that you take all the elements of the collection and reduce it to a single element. Hence, we are having only single element. Map itself says that you map each element of the source collection to something else in the destination collection. So there is a one-to-one mapping. Hence, map higher order function returns a collection. In a similar fashion, filter. These are the four APIs we learned on the higher order functions on collections, which are very important. This collection could be collection. I'm giving it as a generic term. The collection could be list. It could be map, hash map. It could be vector. It could be set. It could be array buffer or array. Anything. Or it could be RDD as well. So RDD is nothing but a collection. The Spark that we are talking about, that we will be talking about later as 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 we move forward. So there we have a RDD in Spark. So as of now, that you can imagine it as a collection. That's all. Nothing more than that. So since we are applying the way we are applying higher order functions on collections, in a similar fashion we can apply higher order functions on the RDD. So this is what we saw in the yesterday's session. So for each and all we saw. I will just try to give some more a vector we saw, right? We saw yesterday vector. So just I will try to give a difference between what is vector and what is list. So we know that we have a sequence class. Under sequence class we have linear sequence and we have indexed sequence. In linear sequence, one of the class is list. In indexed sequence, one of the thing is vector. So that's the difference between actually the list collection and the vector collection. List is a linear sequence, vector is a indexed sequence. So what do I mean by a linear sequence? A linear sequence here is the traversal takes a linear time. So if I assume there is a 100 element list, if I define a list, 1 to 100, if I define a list in this fashion, 1 to 100, and I want to access, now I want to access what is the 80th element. So what happens? The traversal will start from the first element and then it will go to the 80th element. So it traverses in a linear fashion. Similarly, 50th element I want to access, again it will start from the first element and go to the 50th. If any 30th element I want to access, again it will go from the first element to the 30th. So the idea here is it is not so good for random access and it is traverses the system in a linear fashion. Traverses the collection in a linear fashion. That's what we call about the linear. So how different it is from vector? Vector is also a collection. Vector is also a collection, but the implementation of vector is a bit slightly different. So they use contiguous memory location. I'm just trying to showcase the internal implementation of vector. We are not doing anything. I am not giving the use of vector, like I'm not writing a program to use a vector, but I'm just showcasing how internally it is represented, implemented. So it has a a 32 element. Why they have chosen 32 elements, I'm not sure. But they allocate a contiguous memory to store 32 elements. This is a contiguous memory. Only if you have a contiguous memory kind of a stuff, we can have a constant access time, which makes it to be an index. So here the 0th element will be there. 0th element here, first element here, second element here, third element here, and so on. We'll have the 32nd element here. So this is how the uh, yeah, here is a question. The question is, what is the difference between array and vector? Array and vector, we'll see that. We'll see that once we understand the implementation of the vector, the difference will be clear. This is not end of the vector. We are still having it. So initially it will be 32 element memory allocation will be done to store the elements of the vector. Now as the data increases, if you increase the data, what happens is it will allocate one more 32 element contiguous memory location. It's always contiguous. When we say contiguous, accessing the any element is a constant time inside that collection. If you want to access third element or fourth element to the base address, you just add +3. So you will get the element. So it will be constant time accessing the element. That's the reason we use contiguous memory location. But if the data is more than 32 elements, one more such thing is created. One more a memory is allocated, contiguous memory is allocated for 32 elements. Similarly, this will go on for long. So we can keep on increasing the number of allocations. As and as data grow, we can have this fashion. But there has to be some reference to this. It cannot be a allocated memory without any reference. Somewhere a reference should be there. They change the actual value. Here it will be pointing to the, they will change. Initially it will be the actual values will be stored here. Later as the data grows, a new memory allocation will be done. Actual data will be stored there, and here a reference or a pointer will be stored. Similarly, this will be pointing here. Similarly, this will be pointing here. Similarly, this will be pointing here. Similarly. So again, if the data grows, the same thing happens. One more level of the, so this 32 elements will in turn have 32 pointers to point to the next 32 elements. So this is how a vector is internally implemented. This is how a vector is internally implemented. So now let's say I want to access 100th element. Now I want to access 100th element. Where would I, let's assume here there are 32 elements, here there are 32 elements, here there are 32 elements. So 96 we got, 97, 98, 99, 100. So 100th element is somewhere here. 100th element is somewhere here. So if I want to access this element, first I have to get the reference to this address, this 32 elements memory locations. So first I have to get this. So this reference is stored here. So first I have to get this. So accessing this element is constant time, we know that. Accessing this element because it is contiguous. Then from there we get a reference to the one more memory location where the 100th element is there. And from here to here accessing is again constant. Here to here accessing is constant time, and from only the traversal is one node traversal, we can say. To access the 100th element we just traversed one node, but in this case if we had to access 100th element we had to traverse 100 nodes. We had to traverse 100 nodes. So if I generalize this, any element that you want to access at the second level, I will call this as second level. Any element you want to access on the second level, there is only one traversal. There is only one traversal. So this is why we call it as the indexed sequence. We are getting the index from here and accessing the element actually through index. So we are able to get it very faster. It is what I can say. If you want to access randomly any event, it is good for random access. So that's the difference between vector and list. If you are going through each record, for any transformation, list is good. List is good if you are accessing all the elements in a sequential manner. If you are accessing all the elements in the sequential manner, list is good. If you are accessing the elements in a random fashion, vector is good. Vector is good. So in most of the big data analytics or transformations or data processing, we go through each element in a sequential manner. So list would be good. So linear sequence kind of a data structure is good in case of data processing. Vector may not be so efficient in that case. So now coming back to, I hope the difference between list and vector was clear.
Pramod, Rajsekhar.
Yeah, Rajsekhar.
See, when I create a vector, right, back then it will create a 132 element memory allocation that is mainly for mainly for address of the element, right?
Yes, yes.
Once I create a vector, it will just create 32 bit element vector.
32 element contiguous memory.
So it will hold only 32 element. It will hold only 32, see, there is a segment, right? 32 is segment, right? If there is a 32 element, I mean, like, you mentioned 0, 1, 2, 3, right?
Correct.
So each 0 location, it will hold a one more 32 element, right? 32 big element.
Yeah, here. This will point to this will contain the address.
So again, there is in that 32 element, we are going to store only one element, or how many elements are we going to store in
No,
that?
here 32 elements will be stored.
Okay.
32 elements will be stored. Here the very first 32 elements, initially only 32 elements will be stored. Actual elements.
The second.
If it grows more than that, now it will not store the actual elements, it will store the addresses of the blocks. 32 element other, where actual elements will be stored.
What about the first level 32 elements? Suppose I have 90 elements, let's say, right? First 32 elements will store in the first level of 32 element allocation only, right?
First 32, I mean, here it will be stored in this,
Yeah, in the first level.
right.
Once that is exceeds 30, if it is 33 element, it will create in the zeroth node. It will create or it will refer the one more 32 element memory allocation, right?
Right, right.
So in that zeroth location, there is the element plus address of the next 32 element uh, memory allocation, or whole address is there in that in the
Uh,
first zeroth element.
Possibly only address will be there. Everything will be moved here.
Oh, is it? All the elements will move to here.
Possibly, I am not sure. I am not sure on that because that may not be. I don't know how internally it is implemented. Whether they will move all the elements. For me, it looks like nothing will be there here. All the 32 elements will be moved here, and a reference will be created. And the other will be empty. This will be empty. This will be empty. Nothing will be there in there. Probably that's how the
Okay.
implementation.
Okay. Yeah.
So the idea here is one is indexed sequence, one is linear sequence. And coming back to the question of what is the difference between array and vector, I think array you cannot increase the size. Array is a constant size, I think. There is something like array buffer or array list where you can keep on adding new element, but to the vector you cannot add, sorry, for array you cannot add new element. It's a constant. And array list has taken from the Java. I think vector is also taken from the Java, but vector you can keep on increasing, and it is a implementation is different, but array is contiguous memory. It is not, if you see here, it is a tree kind of a structure. It is tree kind of a structure, but array is a simple contiguous memory. So that's the difference. So but APIs, I hope Kishore that was clear. I assume that was clear. So the APIs to create a vector is simple. We just have to say vector. We just have to say a vector here. And everything remains the same. So we can apply the map higher order function. We can apply the filter higher order function. We can apply the all those stuff. V dot map, I can say, I can take each element and I transform into x plus 1. I get one more vector with 2, 3, 4, 5, 6. I can write it in a shortcut manner by using this. In a similar fashion, I can filter out something. I can filter something. I take each element and check whether each element is greater than 3. So I only get 4 and 5. In a similar fashion, I can also do the reduce here. So these are the same operations remains here, irrespective of vector or, but in most of the big data analytics we don't use vector. We don't use vector because we have to go through each element in a sequential manner. So a list kind of a structure is good. Hence RDD is also based on such type of a structure. RDD is also kind of a list kind of a structure. So again, to access the each element of the vector collection, we do it in this fashion. So again, as I said internally, it is the apply method that is called. internally, because anything that you want to do on an object, it has to be done through their methods. We cannot do anything by, there is nothing like operators and all here. It has to be through the methods. That's the vector here. Again you can just press dot and then press tab. You should see all the, so there are a lot of other things also. We have reduced left, we have reduced left option, reduce option, reduce right. So I will try to explain reduce and reduce left later, because it's very important. It's very important. Similarly, there is one more is there. In a similar fashion, here is a question. The question is whether all the methods are higher order functions. No, not all the methods are higher order functions. Few are higher order functions and few are not. I mean to say we don't have to know that. We don't have to know that. But when we use it in the code, so even in IntelliJ, we can get to know the syntax. From the syntax, we will get to know that yes, it is a higher order function, because the function is defined in such a manner that it will not take normal data types, it will take a function data type. So through that we can get to know. So if you mean by the syntax, so we know the syntax of a function data type. Input data type, arrow mark, output data type. Using that we can know. Yeah, fold is one more function. It is kind of a reduced function. We will see this later again. Fold left. It is more generic. It is more generic than the reduce here. More generic than the reduce. Similarly, there are sort by, sort with, sorted. Sort by is again a higher order function. We will be looking into these things. Yeah, one thing is there is something called as a, so if you remember, let me say val nums is equal to a list of 4, 5, 6, 7. So there we use something like this, right? Val x is equal to nums dot filter, and I said underscore greater than 5. So this is a function that we are passing which checks whether each element is greater than 5 and give those elements. So we got 5 and 6. Now sometimes I want also the elements which is less than 5 or less than equal to 5. I can say val y is equal to nums dot filter, and I can say underscore less than 5. Oh sorry, less than equal to 5, so that I don't miss any. So we got 6 and 7 in one collection, 4 and 5 in one more collection. So instead of going through each record two times, instead of going through that two times, there is one more API called partition. I can say val x comma y. I can directly assign in this fashion in the form of a tuple. I can say nums dot partition, nums dot partition, and provide one logic underscore underscore greater than 5. So what it does is, so it will check whether all the elements is greater than 5. I mean, it will take the first element, it will check whether it is greater than 5. It is, if it is, then it will put in one collection. If it is not, it will put in another collection. So in one go, two collections will be created, which will contain all the elements which is greater than 5, and the other collection will contain all the elements which is less than or equal to 5. And I will get that. It will return two collections. So it will read two collections in the form of a tuple. I mean to say, if I don't specify anything as a tuple, I represented a tuple because partition method returns a tuple. It returns a tuple where first element is all the true conditions, where the second collection is all the false conditions. So this is how we can return the value and store it, or I can directly store it in this fashion. So if I show it here, just for understanding purpose, so the way we can know here is, uh, so you can see that there is a for each. If you can see the syntax of the for each is a higher order function. It takes a function. The data type, if you see, it takes a function. Cache or checkpoint, all these are normal data types. Sorry, normal functions. If you see, filter is a higher order function. For each is a higher order function. Bloom is a normal function. Map is a higher order function. Map partition is a higher order function. Persist. So this way we can get to know whether it is a higher order function or a normal. But we don't usually try to differentiate. It's all about the problem statement that we want to solve the problem, and we have to just check which API suits us to solve the problem. Or how to access the records from the partition. So we know that this partition method returns a tuple. It returns a tuple. Z is a tuple now. Z is a tuple. I can say val x is equal to z dot underscore 1 will give me the first element of the tuple. Val y is equal to z dot underscore 2 will give me the second element of the tuple. So it is just a tuple. We have to access it. Again, we know that how we can access the element of the collection. X is a collection now, so I just have to use it. I can directly do these things. I can directly do these things here itself. So I can on that I can just say underscore dot one, which returns a tuple on. I want the first element of the first collection. Those things can be directly returned here itself. Dot underscore 1 will give you the first element of the tuple, which is nothing but a collection. To access the element of the first element of the collection, I can directly do. So you can chain it. That's the beauty of functional programming language. We can chain because each function, each method returns something. So on that you call one more function. You can chain a group of functions. There are other methods also. There are other methods also. even I haven't used all the methods. As and when where there is a requirement, I can keep on looking for the new methods that can be used. So let me know if you want to understand any of the one method, so we can look into that. So we can use array, we can use anything. In a similar fashion, there is one more data structure or one more collection, that is nothing but a map. Capital M map is a collection. Is a collection. Small m map is a higher order function. So this map is similar to, it is like hash map in Java, where we have key values. Where we have key values. So the syntax is a bit different as compared to Spark, as compared to Java here. So mostly we use a hash map for a lookup purpose. So I will define the identifier name as lookup. So then this is how we create a map collection. So I will say we will have some key and some value. So each element of a map collection is, this is first element of the map collection. And the syntax used here is in this fashion. Then I can say Java, then I will say, so you can see that this is how the map collection is created. So if you remember this syntax we used earlier also, if you remember this, it will create, this syntax is used to create a two element tuple. So if you remember, it was always used to create a two element tuple. And the use case of this syntax, the use case of this syntax is to define a map collection in Scala. Map collection, a key value collection in Scala. So what I can say is, a map collection is nothing but internally it is a collection of tuples. Hash map or in this case we call it as a map. It is nothing but it is a collection of tuples. So this is the first element, this is the second element, and this is the third element. So how can I access the elements of the collection? How can I access the elements of the collection? So since it is used as a lookup purpose, since it is used as a key value collection, so I can use the lookup and pass the key here. Pass the key here. It returns the value for that key. It returns the value for that key. So as I said that these things is internally calls the apply method. Whenever I say this, it is actually internally the apply method is being called. So we can clearly see that there is a totally different implementation of the apply method. In list, it is used to access the elements of the collection. The apply method is used to access the elements of the list collection. In the map collection, it is used to get the value for a particular key. So different implementation, that itself says that apply is just a simple method as any other method, The only criteria is, or only property of that apply method is, we need not call this by name. It need not be called by its name. We can skip the name at all, which gives a good use case of accessing each element. And if I say something, if I specify a key which does not exist in the collection, obviously we'll get a error. So we get a, so here is a question how Scala will take care of type safe in collection. Can you elaborate more on the question, Rajshekar?
Uh, yeah, Prabhu, yeah, my question is like, map is having first pair is string, second pair is integer. So how that will take care about that, like whether it's suppose in Java we are having generics, right?
So sorry, I lost your voice.
Yeah, my question is like in Java we are having a generics take care about homogeneous data type, right?
Right. I mean to say we talked about the type parameters. If you remember, we talked about the type parameters. So that's the generics in Scala. So if you see, I always wrote collection of type A. F takes a function of type A. F is a function of type A and returns B. This is our type parameters. Type parameters is similar to Java generics. So 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 that's the reason we are able to create a collection of any type. So we can have a collection of this, we are having a collection of this, or we can have a collection of anything. So here key data type is string, key is a string data type, value is also a string data type.
Can you make it Scala is an int instead of Scala?
Come again?
Yeah, in the Scala, right, there is a key name S and value is Scala. Instead of string, you can mention string integer. Here,
So as I said, it will take the common parent data type. Any is the common parent data type. So now the compiler doesn't know what is the actual data type of the values. It doesn't know this is an integer. It doesn't know this is a string. It doesn't know it is a string. It only knows that it is a any data type, because this is string and this is integer. It always takes the common parent. If you see the hierarchy, the common parent will come as any. So but usually we don't do this. Usually the collections will be of the same data type. Same data type.
but like generics, it will not do any compile time error, right?
No, compile time errors will get if you try to do any operation, because now it doesn't know anything about these things.
Yeah.
We have to check whether it is an instance of integer, then we can do something. Any operations you are trying to do, again also, I cannot call a method called substring on this. It will throw an error. I cannot call a get the substring of this this because it doesn't know that it is an integer. Later while runtime it will figure out that it is an integer and substring will not work. So we have to, the developer has to take care in that case, but we usually
Yeah.
don't do that.
Okay, but it's not like a more about type safe. Developer has to take care about that, right? But in the Java, right, in generics, if we define a string and string, it is not allowed to take integer and anything else apart from string. So more type safe as compared to the Scala, right? In Java.
No, Scala is more type safe.
How come? Because here it will allow, right, both a mixture of both values and string and values.
No,
Can you
it,
make it, is
uh,
it possible to make, yeah, sorry,
go ahead, Rashikar.
is it possible to make only a map will take a key as a string and value as a string?
Can we make restrict that?
Yeah, yeah, one restriction that.
So in that case, let me of the type we have to explicitly say string comma string, and if I say here 5, let's see. So it gives a, sorry,
Pramod, you missed the G
yeah,
in the first string.
yeah, what I'm doing.
Look up size. No, look up size.
Come again.
Look up size. Where val name is look up size.
Yeah, that should not matter. I think it is a map collection of type this. It should give some. So you can see here error type mismatch. Found 5, but we have said that it has to be a string and the value also has to be a string. But we are trying to specify 5 here. So we can explicitly specify the data type whenever you want to restrict it here.
Okay.
When we leave it to the compiler will take anything. When we leave it to the compiler, I mean to say Scala is type safe. It is type safe.
Pramod, I have a question on this map collection. So is it mandatory to have the key and the value?
It is. It is.
Okay.
So the map collection use case itself is as a key value pair. So you specify some key and it will get a value.
Yeah. Okay. Thanks.
Like Pramod, Rakesh.
Yeah, Rashikar.
Like in Java, like hash map, we're having one null key and multiple null values, right?
A key and with multiple values.
Yeah, my question is in Java, right? Compared to Java, in hash map, having a one null key
O-
and it can be multiple null values.
okay.
But in map, in Scala, how exactly works? Like if the null key is allowed, and I can use the multiple null values for different keys.
Multiple null values for different key. So just we can have a collection in this fashion also. I can have a collection like, I can say S as the value could be a tuple also. Something like this. So but I need to check the null value. So we can have multiple values for a key, but it has to be a U in the form of this. So we can have a key value pair where for a key we have these things. Or we can have a list also. We can have a list as the, here I am having the value data type as a tuple. The value data type I can have a list collection. So for each key I will have a list of collections. Null value I need to check. Null value, I am not sure whether null value is available here or not. Let me check whether there is a null object can be specified here. Value is not a member of I'm not sure about the null value. Let me check on that. So that's the question, right? Whether we can have null as one of the key.
Yes.
So that was one question, and whether to have multiple values for a key.
Yeah, multiple null values for the key.
So we can have multiple values. What do we mean by multiple null values for the key?
I mean to say like yes is null and J is also null.
Oh, okay. Okay, the same value or the null
Yeah.
value.
Yeah.
Okay, okay. Just let me do it. Just check this. We can have the same value here. But you are checking about the null value I need to check. But we can have the same value for two different keys. For two different keys.
No, no, not like that. J is null key, null value.
Right, right. I will just check on the null value. I will check on the null value. How we specify the null value. Let me check on that. Probably I will send a mail with that code. I haven't tried that null value. I will. So I have lookup as usual. We have the key value pair here, and we saw how to access each element of the. We saw how to access the values by providing the keys. Internally, it is the apply method that is being used. In a similar fashion, I can also get all the keys from the collection. I want only the keys from the collection. So this is our collection, which is nothing but a collection of tuples. We know that a collection of tuples. This is third element. So I want to get all the keys S, J and R from my lookup map collection. How do I get all the keys? So I can use lookup dot map. We know that map internally goes through each element, does a mapping from one element to another element here. So it takes each element, map takes a function, and that function takes each element, and that element can be represented as an underscore dot underscore. We know that underscore is a tuple here because map is a collection of tuples. Dot underscore 1 will give you the first element of the tuple, which is nothing but the this. So we are transforming each element, a tuple element, to a only a only a keys collection. In a similar fashion, if I only want values, my mistake, why I'm writing values, underscore 2 I have to write. So I can specify in this fashion. So, but there are built-in methods available. You can also use this if you want to do some customization, but there are also built-in methods available like keys and values. There are values, built-in methods. And all other methods also works fine. The map higher order function, filter higher order function, or the reduce higher order function, or the for each higher order function. All these higher order functions works fine with the hash map as well. There is if I want only the values to be transformed, what I mean here is I have a collection in this fashion. So I have values, key value in this format. I want to transform this collection as S as 5, J as 4 and R as 4. I want to transform this collection as a transform the length of the string. Give one more collection where the value is nothing but the length of the string, not the string itself. So how can I do this? So obviously I can use the map transformation. Obviously I can use the map transformation. So we know that each element, I take each element, from that element keep the first element as it is. Keep the first element as it is. Take the second element is nothing but a string. Scala or Java or Python or Ruby something. That string, what we can do is there will be a length method or a size method. Length method or a size method. So we can do it in this fashion. Or we can write it in this fashion also. So we transform the map collection to one more map collection where the value was replaced by a value such that it is a length of the string. Length of the string. So I hope this syntax was clear. Syntax was clear. We take each element, we know that how the map higher order function works. Probably the people who missed the yesterday's class, the syntax may be a bit alien type. The syntax may be a bit alien type. I would recommend to go through yesterday's video. It will be very helpful to understand this syntax. But instead of doing a map, there is one more method that is available. Lookup dot map values. So what does map do? Map takes each element of the collection and transforms into something. So in a similar fashion, map values, what it does is it will keep the key part as it is. It will only transform the values, only do the mapping of the values. Keys will be kept as it is. That's what we say map values. Transformation will be done not on each element of the collection, but the value of each element of the collection, and the keys will be kept as it is. So it is also a higher order function which takes a function. That function takes only value part. That function takes only the value part, and I will say value dot size. It does not take the whole element. It only takes that function takes only the value. And the key is kept as it is, we achieve the same thing. We get the same result. So that's the difference between map and map values. The keys are kept as it is and the value is only mapped. So I hope that was clear. So these are all the different collections that are available, and we can keep using these collections. We can keep using these collections.
Pramod, last week, right?
Yeah, Rashikar.
Yeah, okay. This is fine for single values, like a single key, one key and single values, right? In
Correct.
case of tuples, right? Tuples like it may have different data types, right? How to restrict that, you know? I understood that. I got the point. If there is a single key and single values, you can restrict that data type. But in case of string key and tuple values, like tuples may have a different data record, right? Right? Different data type, right?
Yes, yes.
So how to restrict that? Is it possible in the Scala, like you can restrict that tuples? First in the values, right? First is string, second is int, third is kind of float, kind of.
Yeah. Again, the restriction we have to explicitly specify the data type. I'll just say
What is
map. I want the key to be string, and I want value as this. What happened here? Oh, minus one. Why I gave the. So this should work. But if I try to give something else here, like true or false, so it should give me a error. Too many arguments error. Anyway, it doesn't allow you to add an element, I mean to say specify different data as a value, but the error is a bit strange for me. It says too many arguments for method this. Too many arguments for method this. So this works. So this way we can restrict, but I'm not sure what the error it is giving. But earlier time we got the a clear cut error that we were expecting some data type, some other data type of that. But this way we can restrict. We have to explicitly specify what has to be our value data type and what has to be our key data. So we can have a data type in this fashion also.
Okay. Pramod, one question here.
Yeah,
Like in the tuples, there can be two values, right? In the tuples, like Scala and int, right?
correct.
Uh, how to access? I want to change the Scala only. I want to change that Scala. Is it how to do that? And I mean, like how to access particular first record in the tuple, the first value.
Oh, okay, okay. So let's say so. This is our collection. L is a collection whose key is a string, whose value is this. So we can get the key value. So I can just say val v is equal to L of s. Pass the string key and get the value. So v contains the value now. V contains the value. Value has been returned. V is a tuple now. V is just a tuple. V dot underscore 1 will give the first element. V dot underscore 2 will give me the second element.
Okay, how to do that in a chain? Method chain, like map values. Is it possible? Like map values, right? Uh,
Yes, we can do that. Yes, we can do that. Let me have one more here. I would say J here. I can say Java, and I will say 4. I think Scala length is 5. Let's see. So on that, now I want only the first, only this Scala and Java. From the values, I only want the first element. So I can do actually the map transformation or map
I want to
values also
change
I
that.
can do. Pardon?
I want to change that value. So still that value should be print 5 and 4. Instead of that, I want to change that particular value. Like Scala and Java, I want to something.
Your voice got broken, but I will just try to change something. Again, it's a map transformation. Again, it's the map transformation. So you can change it to anything. I take each element, or I want to change only the map values. Now each element is a value here. Each element is a value. So that value I will change value underscore 1 what I can do. So I can write a in this fashion. I want more than one lines of code here. So I can say new value is equal to value dot value dot underscore 1. So I will just take the Scala part here. I'll just take the first element of that. character, first character of that string. So v means the value, v means this, v means this here. V underscore one will give me this string. V underscore one will give me the string. String of 0 will give me the character. It will give me the character. Then I return what I want to return from here. I want to return this new value and the old value as it is. Old value as it is. So I have changed it to S and J. In a similar fashion, I can change it to anything also. I can change it to anything as well. So I take each element, not each element because I'm using map values. If I use map, it will be each element. If I say map values, it will take the each value. And each value is being transformed. Takes the values, get the whatever you want. Any logic you can give it here. Based on that logic, you can get transformed. Finally, you want to return a tuple. Because our value is also a tuple. I said that whatever is the last expression in the block of expression, that will be returned. This will be returned from that function. And first element of the tuple is a new value that we got. Second element, I'm keeping it as it is. Keeping it as it is. So I hope, Rajshekhar, that was clear. Oh, you need two characters.
Yeah. Yes.
Two characters, we can concatenate it as the first and two characters. You can also use a substring from the from 0th index to second index. 0th index to second index. We can use that. Anything I can specify. Anything I can specify. It's all the logic. You can write your own program here. This is actually function literal. This is actually a function literal. You can pass any function which does a. So how does that substring look like? So we can use this code. There is a Java substring. From 0, then the length. 0, the length. 0 I can specify 2 here. V is a V dot underscore, you can say something S1. I can use any number of variables, language dot substring. So I can use this. Then finally I can say s1 comma b dot underscore 2 and so. B dot underscore 2, keep it as it is. So we should get this. So I mean to say you can write any logic here. This is just a function. This is just a function I'm passing, and I can do any logic. So to understand this, I mean to say just to get a clear view, I can write a method called change value. It takes each value. It takes a tuple of type string comma integer. It has to be the same type as the collection's value type. I'm just reversing it the things. So I will take val language is equal to t dot underscore 1 is my language. Val string, one more string I will say val s is equal to language dot substring of 0 comma 2. Then we return s comma t dot underscore 2 here, t dot underscore. So I'm just passing this function change value. We can say l dot map values. Just pass this function. We are just passing this function. Change value. We can define a function. We have seen all these things in the yesterday's video. We can define this one. This function I'm passing here to the map values, and we know that it takes only the values and the values data types of the collection, and this function should map, otherwise it will give a error. So instead of writing a function, I directly use the function literal. So this is my function literal. So we saw this. We can write it in any fashion. Either you use a function literal, or you can write a function, and here you can give any logic that you want. So it will just transform the data based on this logic. Based on this logic, it will just transform the data. And the whole logic can be passed as a function literal. So I hope the things were clear.
Pramod, I have one more question here.
Yeah.
Yeah, okay, that transformation is done using the map values. But I wanted to print the for each loop. How to do that, for each loop, right? I want to print the values of both string and int, the modified values of string and int, right? When we have changed value in a function is there, right? Here we are passing tuples like one is string and one is int. We are modifying the string like 2 characters. I want to print through for loop. How to do that? Because uh,
No, print is nothing but we need to use the for each. Instead of map values, just use the for each higher order function. So you can just say L dot for each take each element. We know what is each element. Each element is nothing but the whole thing. Whole thing is the each element. So here I can
just want
I can just say println e dot uh, underscore 2 dot underscore 1. So we can print it in this fashion. We know that a hash map is a collection of tuples. This is one tuple, this is one more tuple. to access the value underscore 2. Sorry, to underscore this is one tuple. This is a tuple. This is the first element of the tuple. This is the second element of the tuple. Hence, underscore 2 will give the second element of the tuple. That itself is one more tuple. The second element itself is one more tuple. To print the first element, just say underscore 1. To print the second element, we can say underscore 2. So this way we can print it. We usually use the for each higher order function to print something. Because it has to return in unit. It has to return unit. So okay, yeah. So let's move ahead. These were all about the collections. These were all about the collections. There are other methods also. As we move forward, probably we will see some of the methods. But even I haven't used most of the methods. If you see, even these are methods. Even these are methods. As I was saying earlier, symbols are also being used as methods. Symbols are also being used as methods. Even I haven't used all the methods here. This method is to add an element to a hash map. Plus will add an element to a hash map. So what I have is, let's say I have lookup, how it looks like, a simple Scala Ruby. I want to add one more. I will say lookup1 is equal to lookup. Plus method is there. Plus method takes one more tuple where I can say p as next element. So this I can say val lookup1 is equal to existing lookup plus an element. So it will add an element to the end of the collection. We got one more key value pair. So if you want to merge two collections, so I can say val lookup 2 is equal to lookup plus lookup 1. So lookup 1 is this whole thing. Lookup is nothing but this. I want to add all the elements in this fashion. So I can add it. Again, it is a key value pair, right? So it will just give me the same thing. That's my mistake. If it was a list, it would have added everything, but it is a key value pair. So we should have the only one key and it works fine. So here I could have added the best result would have been, I have lookup is this, I will have one more lookup as so I have two hash maps here, two map collections. If I want one more which concatenates both, instead of saying concatenate, which gives both the result, I can use lookup plus L. Lookup plus L. Plus I have to use because it is not an element, it takes a. So we are merging two map collections. So plus is the method that is used. Plus method is used to add an element to a map collection. If you want to merge two map collections, plus. So different symbols are being used as a different methods here. I have some methods, not all the methods I have used. So but that's what the collection is all about. That's what the collection is all about. You can find all these examples here, a bit different examples also. You can try out all these examples. You can try out all these. We will see the const method later. We'll see the const method later. So filter, partition, we'll see sort by as well. So if you see sort by is one very generic function, very generic function. So if you remember, let's say I have val colors is equal to a list of, I have blue, I have yellow, I have red, I have green. So I have a collection of string, collection of strings. Now I want to sort it. Now I want to sort it. So there is a method called sort by. Sort by is again a higher order function, again a higher order function that takes a function. So the higher order function is a bit complex here. Something else is also there, but that we will discuss later. I'll just give sort by. There is a function. We have a collection of type A. Of type A, it takes each element of the collection, hence it has to be type A, and it returns B, and something else is also there. We'll see this later. We'll see this later. So what does this sort by do is it takes a function. It takes a function as an input, and you can give any logic in that function. You can write any function which returns something, which returns something. So based on that return value, the sorting will happen. So based on the return value, the sorting will happen. So that's the use of a sort by. It's a bit generic way of sorting your collection. So you can give any logic. Based on that logic, the sorting, it's not based on the logic that sorting will happen. Based on the return value of the function, the sorting will happen. So if I want to sort by the length of the strings, I want to sort it by the length of the string. So red should come first, blue should come second, green should come third, and yellow should come fourth. So how can I do that? So I know that sort by takes a function, and I want to return the size from that function. Obviously I can say get size method, which takes a string, and let's say it returns s dot size. So this is a function. It takes a string that has to match. I mean, whatever input you give to this string, that input data type should be same as the collection data type, because we will be passing each element of the collection to this function, because the sort by takes a function, and that function is called for every element of the collection. Hence it has to match. This has to match. So what I can do here is now on colors dot, I can say sort by, and I can pass get size method. So it will get the size for each string. So it will get the size for each string. Get in the sense it will return the size. So based on that return value, the sorting will happen. That's what I wanted to say here. So we can pass any function and based on the return value of that function, the sorting will happen. So in our case, we are returning the size. So based on the size, the sorting will happen. So we can clearly see that now red came first, blue second, green third, and yellow fourth. I can also say in this fashion, underscore dot size, underscore dot size, which is a more shortcut way. We did not define this function. We need not define this function. We can directly use the literal of the function. Again, on that literal, we can again apply a shortcut and then say underscore dot size. So let's say what is the question. Here is a question, how to do it in the descending order. How to do it in the descending order, we just have to say minus here. So we can clearly see that yellow came first, green came second, then the blue came. So that's how we can do it. So a sort by is a bit generic. I mean to say you can give any logic, based on that logic the sorting will happen. Based on that the sorting will happen. So we can have a something like this, right? We can have name age is equal to a list of user with name. I will say it is, let's say it is a collection of tuples. I will say Sam, I will say 25. Second element is something like this. John, comma 35. I have third element as, okay, string. I can say Mike as 20. So it is a collection. So now I want to sort it by the age. I want to sort it by the age. So how can I do that? So obviously I can use a sort by. I can use a sort by name age I have dot sort by, take each element. We know that each element is the a tuple here, dot underscore 2 will give me the second element of the tuple, or it will return, this function will return the second element of the collection. Based on the return value we are sorting it. Based on the return value we are sorting it. So Mike came first, Sam came second, John came. So this way we can write any method here. We can pass any function, and based on that return value the sorting will happen. The sorting will happen. Yeah, there is something called as a flat map. So this is one more thing we have to remember. This is also used very much in the Spark code. I didn't get the question. I didn't get the question, Rajshekar.
Yeah, suppose, like, if we start by, so in case of the descending order, right,
Mm-hmm.
in case of descending order, we know that we use the minus plus the literal we are using that, right?
Okay.
Uh,
Okay.
but how to, in case of, if you use higher order functions, we have to use the same minus there in
No,
front
there
of
is something,
higher.
right, right. There is something different. When we pass the function directly, we have to do something different. Just let me check on that. We attach, it is actually attaching a negative sign to this size. Attaching a negative sign to this size, which will return a minus value, which will return a, so now here I can use, what was that, colors dot sort by get size. So we are returning a size but as a negative value. So bigger the size, negative value, very smaller the value. So we are doing this. So that's the logic is being applied. This negative symbol is not related to the sort by. Sort by does not understand anything related to minus. It does not take a parameter as a negative. It is actually the body that we are defining. So if you want to do the same thing with the descending on the age, if I want to, we cannot have a negative get age. I will take each element, name age is equal to name age dot sort by. I will take each element here, so I can check in this fashion. I can write a function if e dot underscore 2 is greater than, okay, this no, we cannot do this in the descending order because we don't have access to the second element. We don't have access to the second element. Again, age also we can specify as a negative values. Age also we can specify as a negative values. Let's check that. Minus should work, yeah, that should work. Minus underscore dot underscore 2. So it should give in the negative values, a descending order. But again, what is internally happening? What is internally happening? So get age. So I can define a function get age here, which takes a tuple, of the type string, which is the name and the age. And I can say value age, val age is equal to, oh, why did I write age there? I kept on saying age and I typed age itself. Age is 8. T dot underscore 2. I will just write return negative age. I will just return negative age. So we can sort it by this. Name age dot sort by get age. It returns the age as a negative value, and based on that negative value, the sorting is happening. The sorting is happening. So, but if you want to specify the logic, there is one more method called sort with. Name dot name age dot sort with. So if you see, it takes two consecutive elements and returns a boolean. So we can use this fashion. It is also a higher order function, that takes two consecutive values, compares among them, and returns a boolean. So this logic I can use here. I can take each element E1 and E2, I will say E1. It is as same as the uh, and I can specify the logic here. If E1 is greater than element 1 dot underscore 2 is greater than E2 dot underscore 2 underscore E2 dot underscore 2, return true, else return false. So I can use a function literal in this fashion. So which will again sort it in the descending. This is a function literal where you actually specify the logic. Comparison logic you specify. Sort with takes a comparison logic. Sort by takes a logic. On the return value of that logic, the sorting will happen. Both are a bit different. Sort by takes a function. Based on the return value of that function, the sorting will happen. Sort with is again a higher order function that takes a function, and in that function you actually specify what kind of logic you have to specify. So but we can achieve the same result using the sort by also, using sort by or using the actual logic. So this way we can do things. Sometimes the negative sign may not work in the descending order. Sometimes we may not be able to sort this. Age is fine, some things are fine. But if we are not able to sort in the descending order, we can use these kind of a logic. This kind of a. So I hope the sort by and sort with was clear. Actually there is more to sort by. There is more to sort by. We only have seen the a bit of it. Once we learn about the implicit functions, implicit definitions, implicit values, we will get to know more about the sort by. How it internally sorts is a bit different. How it internally sorts is a bit different. So I hope everybody are in the same page. I hope I was able to convey the concepts to everybody, because I didn't get more questions from others. Did I divert somewhere, or is it fine? Or I was able to convey the concepts of Scala? Yeah, good. Okay. Thanks.
Pramod, I have one question. So in Java, actually, when we compile Java class, it will be dot class file be created, and after that, interpreter converts it to and we'll get the output, right?
Correct.
So in Scala, how it works?
In Scala also it's the same thing. When we compile this code, we actually get a dot class. It's a Java
Okay.
based. It is actually finally it is a Java code itself. I mean to say, it will be dot class file. If you decompile it through some decompilers, you will actually see the Java code there. So it is also the same thing. You will get a dot class. So I wanted to show some.
And what about main method and all? Do we have main method
Yes,
similar to Java or?
yes.
Okay.
It is my. Yeah, these questions are arising because I did not show it in the IntelliJ. We have to write the main methods.
Right.
I haven't discussed anything about this object yet. So going forward, we will be discussing this. Then finally, we will understand all this. It's a combination of both object-oriented and the object-oriented and functional programming. If you see, there is one more class, my class. So this is all the methods are defined here. All the methods are defined. We define methods, we define a class. All those are same in Scala as well, similar to Java. Along with that, they have added the functional programming stuff. We will be discussing this project. This is one of the uh, vehicle monitoring application. We will be discussing this. So keeping this in mind, reducing, we saw these are all some functions. A pattern matching is there. So pattern matching. Did we do it now? So I will take the pattern matching on collections. So let's take that itself. So we talked about pattern matching, if you remember. If you remember, we talked about the pattern matching. So we had expression, then we have the match keyword, then we have the case. And the underscore is the default case. Underscore is the default. This is what we saw, but we only saw it for the primitive data types. Value binding we saw, or the primitive data types we saw in this fashion. Or we had the value binding here. We also had the pattern guards here. We also had the pattern guards. Or we had the default case. So, but all these things we saw for primitive data types, normal, integer, or those things. Now we can see how it works on a collection or a complex data type. Collection or a complex data type. So we can have something like this. Val I can say status is equal to a list of I will say 500 and 200. I have a collection in this fashion. So I can do a pattern matching on this. Match expression can be used. I can say val message pass status itself. Earlier we used to pass normal identifiers. Now this is a collection identifier. So obviously the case should also be a collection. So I can say here 200, 500. I can say success, something, anything I will write followed. Critical error. I think it should have been the reverse way. Critical error followed by success. Anything you can write. I can say case list 500, comma 200. The same thing, success followed by critical error, something like this. So I can write a pattern matching on the collection itself. Pattern matching on the collection itself. So not only it uses the primitive data types, we can have the complex data types also like collection. So we have our status as a list of 500 and 200. A list of what it defines is what is it will match this pattern only if it is a two element collection. First element is 200, second element is 500. Only then this case will be matched. That's what it defines. So obviously the first element is not 200, the first element is 500. So hence it did not match here. Hence it matched the second one. So we can write anything here. We can write anything. So I can also say status case. I can write in this fashion. 200 comma x. This is the value binding we are seeing. This is the value binding we are seeing. And I can just return x here. I can just return x. Or I can say case list and I will say 500 and value bind it to y and return y here. So what happens here? A status is being passed as a to the match block. So then the first element is 200. The second element of the status, which is nothing but the second element of the status, will be binded to x. If at all the first element is 200, if at all the first element is 200, bind the second element to x. That's what the pattern defines. So if that condition holds good, x will be returned. In a similar fashion, this case says that if the first element is 500, bind the second element to the y and return y. So obviously 200 will be returned. The second case matches. So this way you can use a match expression with complex type. So the idea here is to extract values. The match expression with what is the use case of match expression with complex data type? The use case of match expression with the complex data type is to extract values, check and extract. We checked whether it is a 200, then we extract it. So that's the idea behind match expression. Check and extract or just extract in a much better fashion. Check and extract or just extract. Extract certain values from the complex data type. So one thing we saw here, right? So if you remember, so we have a collection like this. Val name age is there, right? So instead of this, I have in this fashion. Name is this. I have age and city. Age and city in this fashion. I have age and city here. I have age and city here. Or did I miss anyone? I think I missed something. So I have a age and city as a collection. If you see, this is a collection of nested tuple. It is a collection of tuple, and the second element of that tuple is again one more tuple, So now I want to extract the city from this. I want only the city from this collection, all the cities that are available. Obviously I can use the map higher order function. I can use the city is equal to name age dot map. I can take each element. And dot underscore 2. Each element is nothing but this. Each element is this. So it takes each element. Underscore 2 will give you the second element of the each element. Second element of each. Second element itself is a tuple. Dot underscore 2 will give you the second element of the nested tuple, which is the Bangalore. So we got Bangalore, Hyderabad and Chennai. Now it looks a bit odd here. So if you have some 3 or 4 nested structure, so it becomes a bit odd. Here. So this we can use with the match expression also. This we can use with the match expression as well. The way we use it with the match expression, actually what we can do is we can combine both match expression and the map in this fashion. Map and match can be combined together, and I can say a tuple itself I can specify. If you see in the match, we actually specified list as a complex data type. I can also specify tuple, which is also a complex data type. Tuple is nothing but what? Internally it is implemented as a class. So I can just say first is name, value binding I am doing, then I am doing age value binding, then the city. So this will be matched. This value binding will be done for a 3-element tuple. From there I can just return city. So this is more readable now. So if you see, this is more readable. So we can use in this fashion. This sorry. So if you see here, both will give you the same result. Both will give you the same result, but it may not be. Yeah, here is a question. Can we use match instead of map in this expression? So we can use that. But that doesn't solve the problem, or that doesn't make a much more sense here. So we have to go through each element. So usually match expression is used to match each element of the collection. The use case I am talking about here is how match expression benefits on complex data type. So we can use that as you asked, we can do that. So but it doesn't make a much sense. So I can say val city is equal to list, sorry, my mistake, what was that? Name age, pass to the match expression. We are passing the whole age here. Sorry, my mistake. We are passing the whole collection itself, list. So case in this So we have to use list. This doesn't make sense. This doesn't make sense much. So I have to specify each element here, x, comma, y, comma, z. Then I have to return x dot underscore 2 dot underscore 2. Similarly, y dot underscore 2 dot underscore 2. Z dot underscore 2 dot underscore. So it is bit of a hard coding. So it is bit of a hard coding saying that this expression will only match if there is a 3-element collection. But we can have 100-element collections. A collection could be, there could be thousands of elements. If you go to the Spark as a RDD, which is also as a collection, we can have millions of records, millions of elements. So in that case, we cannot write millions of things here. So we have to go through the map so that we can loop it internally in a generic fashion. But we can write it, but it is not recommended to write in this fashion. Not recommended to. The main use case of the match expression on complex data type is extracting the values. Just extract the values in a much simpler fashion. Extract the values in a much simpler fashion. So I can write the same thing in this fashion. I can say val city is equal to name age dot map dot math. I can write it in this fashion. Take when you combine those things, I'm not combining here. What I will do is I will take each element. So each element I will pass it to the match expression. I will pass it to the match expression, and here what we have. Here we have a case of the same thing. Case I have name, comma, age, comma, city. So it returns city here. And the match expression is completed here. Match expression is completed and the map is also completed. So this I did combine these two together. These two were combined together in my earlier example. So these two were combined together actually. So it gives more readability. If you see, this doesn't give more readability and doesn't scale. It doesn't scale this piece of code. This piece of code will scale but doesn't give a much readability. So either we use, this gives a bit more readable. We are saying that each element is of a type tuple. We are binding the tuple's value to the name, age and city, and I only want to return the city. So this gives us more readable. Either we use the match expression with complex data type in this fashion to extract the values. That's the use case of match expression with complex data type. And it should give us the same result. If I want the age, I can only get the age. So this is how the things work. So I hope the match expressions with complex data type was clear.
Pramod? Pramod, Rashid,
Yeah, Rajshekhar.
yeah, our question like, in the previous tuple, right, we are having the list having a name, age and city, right? My question is like, based on the name, I need a city.
Based on the name, if you want the city, then we have to use this match expression will be put inside filter higher order function. So we want to filter out something, right? You want to filter out. So you need to have a filter higher order function and specify. So this is the proper way. I hope uh, Rajshekar, that was clear.
Yeah.
Instead of map, just use the filter, and it has to return true or false. It has to return true or false. One more thing, on a big data set, which is an efficient method. So we usually use this way. There is no efficiency, it is only the readability. Efficiency is the same. Most of the time you will see the code in this fashion. Most of the time you will see the code in this fashion. This is the more used, this is the most preferred way to write the code. Extract some values. So yeah, Rajshekar, I think I can take up that example later. Based on the city name or name, you want the, or based on the city you want the age. So that conditions we can give. I'll try to come up with that example. So let's wind up the session here, and let's continue tomorrow. Tomorrow we'll see the object oriented things. We will see the traits, objects, object oriented, then implicit definitions and implicit functions, case classes, all those things we will see. So uh, let's wind up here, and let's connect. Cloud, yeah, I think I should have. I will share it, Kishore. On Cloudera Manager there should be, or I lost it. My system got formatted sometime before I uploaded in some safe location. Let me check on that if it is available. And yeah, it's Pramod. It's not Pradeep. It's Pramod. Actually.